Hi guys, welcome you all. And today we are going to discuss about radiation resistance of loop antenna by Ganashiva. And before getting to the introduction, let me know what is the radiation resistance. Here, resistance is nothing but it is the part of antenna, and the feed point of electrical resistance caused due to the emission of radio waves from the antenna only. And this is nothing but about the radiation resistance. And or we can say it is the value of electrical resistance that would be dissipate the same amount of power as a heat. Same amount of power as heat, it will be heated. That is nothing but a radiation resistance. Coming towards the introduction, see here, what is that? Radiation resistance of a loop antenna is the antenna, and is the resistance that would be dissipate the same amount of power as they radiated into the space. Same amount of power it will be dissipated into the space. And here coming to the crucial parameter, and it will determining the efficiency of antenna. See, while converting, where means it will while converting into a power into a radiated electromagnetic waves, there it will be playing a crucial aspect. And we know that radiation resistance depends on the physical dimensions. It will be mainly depends on the physical dimensions only. See, these are the physical dimensions we have. Some equations are nothing but physical dimensions. Here we have the power radiated equation. P radiated is equal to of I naught square R radiated. R radiated nothing but radiation resistance. And we have power loss. Loss power is given by P loss is 1 by 2 I naught square RL. RL means load resistance. And coming towards the factors affecting radiation resistance. Here mainly the factors. What are the factors affecting the radiation resistance? Here this shape and size of the loop antenna. These will play a crucial role in loop antenna, like radiation resistance. The size and shape, which is a main crucial thing, which will be played in radiation resistance. Coming to the material used to constructed the loop antenna can affect the radiation resistance. If unwanted material, which will be through the unwanted material we are constructed, whatever the loop antennas, those will be affected from the radiation resistance. See, we can observe what is the graph vertical antenna and radiation resistance in a free space of lambda by 2 is off. It's a small antenna. It's a small looping. Then coming towards the methods for enhancing radiation resistance. And here adjusting the physical dimensions of loop antenna, such as diameter and number of turns, can helps increasing the radiation resistance. And using high conductivity material for constructing the loop antenna can reduce the losses and improve radiation resistance. And in the next page, where we are going to derive an equation according to the radiation resistance. Coming to us to the next page, where SR we have SR is equal to of RE and E naught H5. H5 is the magnitude, we know that. And we have a Z naught is nothing but E naught divided by H5. Here E naught is nothing but Z naught by H5. We are substituting this E naught here, and the equation will becomes SR is equal to half RE Z naught H5 and modulus of H5 and modulus of H5. Here multiplying this both become H5 whole square and lesser of RE, and here 125. This Z0 will define as a 125. Next, after simplifying this equation, we get SR is equal to 65 H5 whole square. And substituting that SR value in power theorem, this that will be the power theorem equation will become P is equal to double integration of 6 pi H5 dsr. See here we come across in previous phase I written the ds general equation. This is the equation we wrote, and the P is equal to 6 pi. Theta will always represent the angle from 0 to pi, and pi always represents the angle from 0 to 2 pi. Limits. It is a limit representation. And h pi whole square r square sin theta d theta t pi. And if taking the for small loop, because we used here a small loop, right? That's why taking a small loop, h pi is equal to beta a im divided by 2r ji beta a and sin theta. This is the small loop equation. And squaring, according to we have here square, right? By squaring this h pi whole square and beta square a square im square and divided by 4r square. Here j1 square and beta a sin theta. And substituting this h pi whole square value in this power theorem, and substitute that p is equal to 6 pi, limit from theta 0 to pi, and limit of pi 0 to 2 pi. And whatever the h pi whole square we are equation we have written here, beta square a square im square pi r square and j1 square of beta a sin theta and r square sin theta d theta, and place that equation here. And after p is equal to, take out this beta square a square im square for here, see this r square and this r square will be cancelled. And next 6 pi, and take out that this equation out from the integration. Next after 6 pi beta square a square im square divided by 4, here from theta 0 to 5, right? j1 square beta a sin theta and sin d theta, we have sin d theta here. And separating the limits for the separating like theta from theta and pi, here from pi to 0 to 2 pi d pi. Don't have any equations for d pi, just keeping the d pi words. For small loop, c by lambda is less than 5. For that j1 square beta a sin theta we have equation, and beta a sin theta divided by 2 whole square. This equation represented like this. And substituting this equation in here, and p is equal to 6 pi beta square a square im square divided by 4, and theta is equal to 0 to pi and beta a sin theta and divided by 2 whole square sin theta from limit from 0 to, and applying the limits, integration and applying the limits. After applying that applying the integration and applying the limits for theta, and we get the value, is equal to 4 by 3. This is the value we get for applying the limit for theta. And in the next page we come to beta square a square by 4 by 3. This is the equation for this. And see here 4 will be cancelled, and this is the equation we get. And applying the same limit for d pi, and 2 pi will be get, and substitute these two in equation 2 what we have mentioned before. P is equal to 6 by 4 beta square a square by 3 into 2 pi. Here after simplifying this whole equation we will get 10 beta power 4 im square pi by square a power 4. Yeah, we know that considering area, that area is equal to pi square a by 4 and pi a whole square of whole square, that will be a cube, it will become. And substitute in the here, no here. And after that p is equal to 10 p power cube a cube im square. And comparing this equation 1 and 3, after comparing these two equation 1 and 2, we are going to get rr value 2 beta power 4 a cube a square, r is equal to 2 pi by lambda whole power cube a cube, and r is equal to 20, and 16 we are making 16 2 power 4 16 and pi power 4 all power lambda power 4 a square, and 320 a power 4 85 a square by lambda power 4, and this is the value we get 31.171 a by lambda square and whole square. For it is for the number of turns, and finding for number of turns we are going to get 31 r is equal to 3120 R is equal to 31 3120 31,200 a divided by lambda square by whole square and n square. This is for the n, for the n terms, and this is for today's class. And do like my video, don't forget to do the like, and until for the next video, bye.